Hello guys, in the last video we discussed about pointers. The very basic nature of a pointer is to store address, and from that address how we can store value, that all we discussed. In this session we'll be discussing more about pointers, how pointer is associated with an array, and how pointer can be used to access structure elements, that we'll see. Let's have an array with us for analysis, and this array we'll use as a pointer as well. How that will go through one by one. So this is very important concept as far as data structure is concerned. So be with me during my session. I'll be disclosing many facts related to pointers, arrays, pointers, structures. At the end, we shall have a demo as well, hands-on session as well about these programs. So let's begin our discussion. Now here I have considered one array, employee ID, and I have made use of static initialization. Directly I have stored the values. After storing these values in an array, how the array looks like. See, this is the way it looks like. Now, whenever we allocate memory for an array, it uses address. So, and you know array uses subscript notation. So the element with subscript 0 is the first element, and address of that first element we call it as a base address. That is the start address of an array. It's very important. Note down, the address of the first element is called base address. And let's say this is the scenario, the way the array is stored. Now if I say like this, what is the name of an array, guys? Here the name of an array is empid, employee ID. Now if I just mention the name of an array like this, guess what's the output of this? Cout empid. What the system interprets it, the system interprets it as a base address. So whenever you mention the name of an array, the system treats it as a base address. It displays base address. It provides base address. So in this case, it is 65110. As we know, base address, we can find addresses of other elements. In the previous video, it's been told to you that we can increment a pointer. When we increment a pointer, it advances by some bytes. The number of bytes depends on the type of a pointer. Now here, since it is an integer array, by default empid pointer type will be integer. So whenever you increment the base address, when you add 1 to base address, it generates address of the next element. Why it is so? Because the characteristic of array, one of the characteristic of array, that is array stores data in contiguous memory locations. So if the very first element is available at 65110, from the figure it is clear the next element is available at 65114, for sure it is, and then next is available at 65118, for sure there is no any different address because array uses contiguous memory locations. So one point is very clear here. If the base address of an array is obtained, we can find addresses of remaining elements. How we can do so? Let's see here. See, for that I'll run a loop for I0, I less than 5, I plus plus. Cout empid, just in the last slide you have seen, if I say cout empid, it is giving me one base address. Now I want addresses of all the elements. So how I generate? By incrementing it, by adding 1, 2, 3. So initially it is empid plus 0, that is base address will be there. empid plus 1, so it advances to the next location, next number, address of the next number will be generated. So this is how for all elements we can generate using a loop. You can see here. Now In the previous video, we have seen if the address of the variable is obtained, its value can be obtained using value at address operator. We can get the value stored at a particular address using value at address operator. What is that? Asterisk star. So if I simply apply value at, if I make the address precede with the asterisk operator, what it does, it will give me value stored in that location. So from here it is clear to you. You can see here. So this is base address, and then I'm adding 0, 1, 2, 3. So I'll be getting all the addresses. At the same time, since a value at address operator is preceded here, it will be giving me all the elements. This is how we access array elements using addresses. So now if I say cout empid 3, it is a subscript notation I have used. Now with the pointer notation, how it will change? 3 will remain an index, empid will be the base address. So to generate address of empid 3, I have to add 3 to base address. So empid plus 2. So if I am talking about another element, it will be empid plus 2 value add, that will be pointer notation. If you want for the third element itself, 0, 1, 2, 3 with subscript 3, index 3, then empid plus 3 you have to use. Now here I have used empid plus 2, so I will be getting value stored at location empid plus 2. Address will be base address plus 2. It advances depending on the address obtained. So interchangeably we can use this one, empid, this way. Note this, this is important relation, that you can use array as a pointer, pointer as a array. So you can ask me one question here, what is the need when directly we can use with simple notation, array notation, why we have to make use of this pointer notation? So the answer is, whenever we have address in our hand, we can directly access the element using a value at address operator. If we use array notation, internally it will get converted to the pointer notation itself. So if I give, so I will be making the system, making the program little faster. I will be reducing the burden of system. Otherwise, the system will internally convert. If I use array notation, the system will convert that one. So now let's go for structure elements now. How we can use structure. Now, in a nutshell, I'll recap the array and pointer. When we declare an array, we have array name. That array name acts as a base address. That base address we can use to obtain addresses of remaining elements. So this is the base address I have, empid. From there, I'll be generating other addresses through a loop. Once I am able to find all the addresses, simply by applying value at address operator, I can store all the values. So this is how array we use, array and pointer. And this interchangeably we can use pointer and array. So once I'll make it clear. If you have an array with you, say int a, this is an array with you. So what is the base address here? A is the base address. So if I add plus 0, it will give me same base address A. A plus 1, if I say, it will give address of element A1. Like this, A plus 2, if I say, it is address of A2. Likewise, I can get all the addresses. Once, if I get addresses, if I simply place a value at address operator, say A plus 2, value at A plus 2, it is nothing but the element A2. So this is how we use pointers and arrays. Now you can ask me one question instead of this way directly. If I write the loop like this, for I0, I less than 5, I plus plus, if I say cout value at A plus plus, then also the meaning is same. Initially it will be A because it is a postfix increment. Initially it will be A value at A, that is the first element, then A plus plus. So A plus plus, that is A plus 1. A is equal to A plus 1. So it will take you to the second address. Then again A is equal to A plus 2. It will take you to the third address. But is it possible? Can I give this way? If I give, what happens? What is the response of system, response of compiler? We'll check in the hands-on session. Now remember this, we'll answer during practical. Now let's go for structure and pointer. How we can access structure elements using pointers. We know C, C++ uses structure concept to define user-defined data type, like struct account. I have defined int account number, that is there. Now I'll create one structure variable, account A1. A1 is a structure variable. Then using this structure variable, I will be initializing the data. So this is very important as far as data structure is concerned, because in every data structure we define normally one structure. Say for linked list we define node as a structure, and in trees again node we define as a structure. In graphs also we use structures. So when we use a structure, and then how we can access its elements using pointers, that's very important. If you understand this, understanding data structure will become easier for you. So pay attention and be with me. Now what I did here, I have structure variable with me. Using this structure variable and address of the structure variable, I'll be accessing the elements. If I say A1, A1 is a structure variable. Address of A1, look at this statement, account star P. So P is pointer of type account, because P holds address of A1. Since A1 is of type account, the pointer should be of the same type. In the previous video, it is clearly explained to you there are pointer types, and what you are storing in it, address of what you are storing, the pointer should be of that type. If you are storing address of an integer, integer pointer you should have. Now I am storing address of a variable structure account, that's why my pointer is account star P. Now here, when I use address, it will be P arrow account number. With simple variables, we use value at star. Now with structure elements, address of structure variables, we will not use value at address operator, we use arrow. Actually, arrow is internally, it is converted to, say, if I say arrow here, internally it is equivalent to value at A1 dot account number, like that it is value at. So right now A1 is an object, but you should take it as a P, address of P, because in P you have address. So once again I'll make it clear. Whenever you have address of a structure variable with you, say P, P is representing address of a structure variable, then value at P dot account number. Internally that arrow will get converted. So we have such a complex structure, that's why it is replaced with arrow. So whenever we use structure element and address of that structure variable, the elements will be accessed with arrow. Say p arrow account number 11. This we'll now see with our program now. Let's go for array and pointer. So what I told, if A is a base address, I can generate all addresses of all elements through a loop for I0, I less than for I plus plus. If simply I say cout A plus I, it displays addresses. Let's run it. So you can see these addresses obtained are all hexadecimal addresses. Internally, addresses are stored or represented using hex number. That's why these are all hexadecimal numbers. So if you are interested, no, let me check it as a decimal. Let me convert it to decimal. Then in C we have unsigned integer. So that is for decimal. Same thing it is. Now when I run, I'll get decimal values. See, you can see decimal addresses. They are not hex. But internally they are hex. We are converting them to decimal and displaying it. So this is clear now. Let me comment it. Let me have cout again the same statement. These are addresses we obtained. So this is the address of the very first element, base address. Then the next, see, it is 0, it is 4, 8. Since it is an integer, it advances by 4 bytes. So if you want to value stored at that location, say simply I place value at address operator, then it will be simply, see, 55, 88 elements. Now what earlier I used to use subscript notation. So subscript notation is A, I. This is a subscript notation. With this also I'll get the same. This is array notation or subscript. But sometime when I need to access them with addresses, then I can use pointer notation. So when I use pointer notation, this way I obtain addresses. Now in my discussion I had asked you what will happen if I say a plus plus instead of a plus I can do a plus plus as well. Let's first see this output. So it is, we are getting it. Now we'll change, we'll make it a plus plus. So this is a very interesting point, guys. Remember this, what is the response, I'll explain you. So what it says, see now. So in function int main, L value required as increment operator. So L value required is an error whenever you try to modify a constant. So what is the constant here which you are trying to modify? As such, we have not defined any constant. But one hidden fact is array name, base address of an array by its name. What is its name? A is constant. So A is constant here as a base address. So when you try to modify, A plus plus is nothing but A equal to A plus I. So A is getting modified now here. That's why it says L value required. Instead of this, if you copy the base address in another pointer, say P is another pointer variable and int star P pointer variable, in that one I'll transfer base address of the array. Now P is base address of array but not by array name. It is a different variable. This can be modified. So now I'll not get any objection. I'll get values stored in those location. So this is one of the important fact you should remember. Normally it is asked in interviews. So hope you got the point. Thank you. Thank you for watching.